Have you ever stopped to think that every time you learn something new, you're literally building a new piece of yourself, of your brain? Well, that's exactly what we're diving into today. See, learning isn't just about memorizing stuff for school. It's the fundamental way our minds adapt, grow, and actually construct who we are based on our experiences. Oh, we've all been there, right? You pull an all-nighter, you cram for a huge test, and then, poof, the information just vanishes the next day. It's so frustrating. But that experience isn't some personal failure. It's actually a massive clue about how your brain is wired. In this explainer, we're going to pull back the curtain on the science that explains why some learning sticks and some just, well, doesn't. So, here's our game plan for today. We're going to start with what learning even is, then take a look at some of the early theories, think bells and boxes. From there, we'll dive into how the mind actually works, the different factors that can shape learning, and then get into the good stuff, how you can learn better. Finally, we'll see how this all plays out in the world around us. All right, so let's start with the absolute basics. When a scientist or a psychologist talks about learning, what are they really getting at? Because it's a whole lot more than just what happens in a classroom. Okay, this is the official textbook definition, but the key words to lock onto here are permanent change and from experience. That's what separates real learning from, being tired, or from the instincts we're just born with. Learning is an active process. It's how we adapt. It's not just something that happens to us. So way back when, to even begin to understand learning, psychologists had to start with what they could actually see and measure, and that was behavior. They couldn't peek inside the black box of the brain yet, so they focused on actions and reactions. And this led to some of the most famous experiments in history. You've probably heard this one, right? The story of Pavlov's dogs. He was a scientist who noticed his dogs would start to drool before they even got their food. So he ran an experiment. He started ringing a bell right before feeding them, over and over. Pretty soon, just the sound of the bell was enough to make them drool. That's it. That's classical conditioning in a nutshell, linking a totally neutral signal, like a bell, to a natural reflex. Then, B.F. Skinner came along and took this whole idea a big step further. He showed that our voluntary actions, the choices we make, are shaped by what happens after. I mean, think about training your dog. It does a trick, you give it a treat. That reward, what he called reinforcement, makes the dog way more likely to do the trick again. This simple idea, operant conditioning, has had a huge influence on, well, pretty much everything. So if you want to boil it all down, here's the crucial difference. Classical conditioning is all about involuntary, automatic reflexes. The learner is totally passive, like the dog drooling. But with operant conditioning, the learner is an active participant. Their conscious choice is what gets rewarded or punished. But, just watching behavior can only get you so far. It doesn't explain what's actually going on inside our heads, our thoughts, our memories, our aha moments. And this limitation led to what's called the cognitive revolution, where scientists finally started to crack open that black box and explore the mind's internal machinery. This quote, it's one of my favorites, from a neuropsychologist named Donald Hebb. It just perfectly captures what's happening in our brains. It's the core idea of neuroplasticity. Every single time you learn something new, you are physically changing your brain. The connections between your brain cells, your neurons, they strengthen. They create new pathways. Learning, quite literally, rewires you. Now, to understand the mental side of things, psychologists often use a model that's a lot like a computer. First, you have to get the information into the system. That's called encoding. Then your brain has to hold onto it somehow. That's storage. And finally, and this is a big one, you have to be able to pull it back out when you need it. That's retrieval. If any one of those steps breaks down, well, then the learning just hasn't fully happened. But here's the thing. We aren't just computers passively downloading files. Theories from brilliant minds like Piaget and Vygotsky revealed that we're actually active architects of our own understanding. We build knowledge piece by piece by connecting new information to what we already know. And we do it through both our own experiences and by interacting with other people. So learning clearly isn't a simple input-output kind of deal. It's this messy, complex process that's influenced by a whole bunch of different things, both inside us and in the world around us. And it goes way beyond just IQ. I mean, just think about all the things that can affect how well you learn on any given day. You can't learn what you're not paying attention to, right? Your motivation is what keeps you pushing through when things get tough. Emotions, they can sear memory into your brain or block it completely. A good night's sleep? Yeah, that's absolutely non-negotiable for locking in what you've learned. And of course, what you already know and who you're learning with makes a massive difference. This all leads to a really important and honestly, a super empowering question. Knowing all this, are we just sort of at the mercy of these factors? Or can we actually use this science to take control and become better, more effective learners on purpose? The answer is an absolute, resounding yes. Okay, this is where the rubber meets the road. This is where the science gets incredibly practical. Let's dig into some proven strategies, all backed by tons of research, that you can literally add to your own personal learning toolkit starting today. Now, there are a lot of powerful techniques out there, but they all have one thing in common. They work with your brain's natural design, not against it. A lot of these actually go against our gut instincts, like cramming. But things like spreading out your study sessions, that's spaced repetition, or just thinking about your own thinking, that's metacognition. These are basically learning superpowers. We're going to zoom in on two of the most effective ones. First up is retrieval practice. You might also hear it called the testing effect. And seriously, this one is a total game changer. The simple act of trying to remember something, even if you struggle a bit, is one of the most powerful ways to strengthen that memory for the long haul. It is so much more effective than just passively rereading your notes again and again. Here's how you can use this, like, tonight. After you've read a chapter or studied something, just close the book, put it away. Grab a blank sheet of paper and just try to write down everything you can remember. It's that effort, that struggle of pulling the information out that builds those strong neural pathways. Next up, we've got dual coding. The big idea here is that our brains seem to process words and pictures in two separate channels. So by combining the two, say by pairing a concept with a simple image, you create two different memory traces for the same idea. This makes that idea much stickier and way easier to remember later on. So a super simple way to put this into action, stop just writing walls of text. As you're taking notes, try sketching a little diagram or a simple timeline or a mind map next to your words. The very act of translating those words into a picture forces your brain to process the information more deeply, and that encodes it much more strongly. Okay, so we've dug into the science, we've got some powerful strategies. Now let's zoom back out and see where these principles actually show up in the world around us. And once you know what you're looking for, you start to see them everywhere. The best classroom teaching is built on these ideas of active learning and retrieval. Therapies that help people overcome phobias often use the principles of classical conditioning. And, get this, the artificial intelligence that powers your smartphone, it's often trained using a digital version of the very same reinforcement principles Skinner figured out with his boxes. It's amazing. So, what's the big takeaway here? It's this. Learning isn't some kind of mysterious talent that you either have or you don't. It's a skill. It's a set of processes that you can understand, that you can control, and that you can improve. You now have some of the keys to the control panel of your own mind. The only question left is, what's the first thing you're going to unlock?